Okay, so pollution, not a great thing. So what do we do about it? How do we try to make things better so that we don't put as much junk up in the atmosphere? Okay, so again, we've got all the stuff that we have to worry about. Smog, talked about this in the air pollution, types of air pollution issue. But the thing, I bring it up again because the deal with smog is we're looking at fog. We can never get rid of fog. So because fog rolls in, we do have this problem with all the gunk that's in the air getting trapped in that fog. So we get a lot of this anytime where we would, release large amounts of air pollution. So how do we prevent releasing a whole bunch of this stuff? Okay. Well, again, because we don't want our cities to look like this. We get this brownish orange haze formed by chemical reactions involving sunlight, nitrogen oxides, and hydrocarbons. So there's all sorts of reactions going on that form it. So what do we do about it? Okay. All right. So there's some of the reactions there that show how photochemical smog is generated. So we've got some oxygen, we've got UV light. We split that oxygen up. Now we get oxygen and an O2 molecule, the oxygen that we breathe, and now we form that ozone. So there's that pollutant there. And then we get a cyclic generation of ozone in smog, and so it goes over and over again. So to start off with, EPA came out with the Clean Air Act. And so EPA is our Environmental Protection Agency, and so they are authorized to set limits and say, hey, enough is enough. So they're looking at 6 main pollutants with this Clean Air Act. They're looking at lead, particulate matter, sulfur dioxide, carbon monoxide, nitrogen oxides, and ozone. So the Clean Air Act has been doing its job. It's definitely decreased things since the 70s. So we've got this. Emissions have dropped 73% between 1970 and 2017. Okay, so that's looking much better. But as we've been seeing, we're starting to see stuff on the rise. And I mean, it was interesting when we were all home during COVID, we started to see, oh, guess what? Our air quality is getting better. Our water quality is getting better because we weren't driving around everywhere and we weren't polluting everything. So, that goes to show that reducing all these emissions and reducing the amount of stuff we put in the air really does help. Okay, what else can we do? Okay, well, we can reduce our sulfur content in our gasoline. So gas has about 330 parts per million. So ppm stands for parts per million. Okay, so we're at 330 parts per million there. So the catalytic converters in our cars, they help keep emissions down, but unfortunately, they get all gunked up from the sulfur. All right. Another way is having federal standards. So basically, there have been talks about, well, if you have a gross polluter, well, you just pay more tax. Okay. That doesn't help fix the problem, though, because people with money who want to keep a specific vehicle will just pay the money and they'll write it off, whatever, who cares? I get to keep my car, whatever, if it, pollutes everywhere. Okay. So, and then looking at a federally mandated emission testing for all vehicles, no exceptions. All right. We also can do stuff with our smokestacks, so electrostatic precipitators. So electro, meaning it's using electrochemistry, which I love electrochemistry because I was trained as an electrochemist. Basically, there's a cathode and an anode. So you've got one spot with a positive charge, one spot with a negative charge. And so the dirty gas goes in, the smoke, and then you've got this electrostatic interaction there where the stuff will drop down, all the gunk, and then the clean air will go out because it will attract all the dirty gunk. So I've got a couple pictures here. So you can see down in the left corner, those are smokestacks without the electrostatic precipitator. And there's smokestacks with the electrostatic precipitator. So this works. It cleans the air really well. Okay. There's also smokestacks that have scrubbers in them. And so you put stuff through there and we process in all of the gunk. And so you can control that with scrubbing. We monitor our air quality. So here in San Diego, here's a few places where we monitor air quality. I've linked one of them on Canvas already for you, but if you pull the slides, here are some other websites that monitor our air quality. Okay, so we get this air quality index, and so you want the air quality to be green. So your region of town, you want to see green. If you see other colors, that means that the air quality is not so great. And as we get into the oranges and the reds and the purples and then the maroon, that's really bad. You don't want air outside of, you really don't want air outside of green. We can handle yellow for a short spurt, but we definitely don't want air getting into that oranges and maroons there. When we've had the big firestorms in San Diego, the air quality was getting pretty bad into those reds and other colors. So what do these numbers mean though? So basically, green, good air quality, little to no risk of pollution. Yellow, okay, it's acceptable, but now we're starting to look at, well, for some populations, it's not so great. So, like, my parents have asthma. So, getting into the yellow and the orange for my parents is not good. That starts to exacerbate their asthma, especially if they're going through a particularly bad flare of it where it's not controlled very well. So they definitely, if we get into yellows or oranges, need to be a lot more careful. And then when we get into red, that's where even regular people that don't have other health issues, they start to see some problems. And then purple and maroon, bad air. Don't want to breathe it. Okay. Here's some recent conditions in San Diego. So you can see different regions of town, yellow, some regions in green, and then saying the major pollutant. So there's an interesting thing here. So ozone, we've talked about that, but then we're looking at this PM 2.5, PM 2.5. Okay, so what does PM 2.5 mean? Well, PM stands for particulate matter. Okay, and so PM 2.5 has a maximum particle size of 2.5 microns or micrometers. And so that's going to get inside your bronchia in your lungs. So there's PM 10, PM 2.5, and so we get these teeny tiny particulate matter things that get down inside of us. And so we'll look a little bit, we're not going to go heavy into math, but I will have a little bit of information about, okay, what is a micrometer? And we'll look at some of those metric prefixes. Okay. And so when we start to figure out what all this stuff is, we use this dimensional analysis technique in order to figure out standards or to do conversions or to put things into terms like, you know, we use micrometers or parts per million. Well, sometimes we might measure something in one unit, but then when we publish the data, it has to be converted to a unit that like everybody's using, because sometimes we have situations where we've got detectors that might record in one unit, but then we have a standard for measurement that's using a different unit, and so to compare to standards, we might have to convert to that particular unit. So there's a lot of things that we can do to help clean up what we're doing, but clearly we definitely have a long way to go. If we started to see things drop, and now in 2024 we're starting to see some places go up again, we don't want that to happen, because, you know, at the end of the day, one thing to keep in mind as we're going through a lot of stuff, because in this course we're talking a lot about pollution and climate change and, you know, what happens to our water. We only have one planet. We haven't figured out how to go to another planet yet and actually set up camp there and survive as a species. So right now, this is the only place we've got. So we have to be good stewards of it and try to do our best to, you know, leave it good for ourselves, but also leave it in good condition for the people that come after us. All right, so that's how we can start to help remediate our air pollution.